And then finally, the reason we factor is so that we can solve a quadratic. Not all quadratics can be solved by factoring, but many of them can, and we can use the zero product property to do that. So let's go through these and see how that works. I'm going to go through each one of these. This will be a good review of all of them. So the first thing I want to do is make sure it's in standard form. A x squared plus b x plus c. So our a, b, and c are 1, 5, and negative 24. I'm looking for two numbers that multiply to give me negative 24, that had to give me positive 5, and I know those numbers are going to be 8 and negative 3. So then this factors to be x plus 8 times x minus 3. The zero product property says when you have two numbers that you multiply together, if you get a product of 0, one of the numbers has to be 0. That's the only way you can get 0 by multiplying. So if I know that these two expressions multiply together to give me 0, then I know either this first expression has to be 0, which means x must be negative 8, or the second number has to be 0, which means x equals 3. And if you were to graph this quadratic, you would see that it has x-intercepts at negative 8 and positive 3. All right, let's look at this one. Again, I want to make sure it's in standard form, and it is. There's no common factor, and so I'm going to go ahead and identify A, B, and C. Two numbers that multiply to give me 12, that add to give me 7. I know from a previous problem that's going to be 3 and 4. So this factors to be x plus 3 times x plus 4. And when two numbers multiply to give me a product of 0, I know that one of the numbers has to be 0. So either x plus 3 has to be 0, which means x would be negative 3, or x plus 4 has to be 0, which means x would be negative 4. And those are my two solutions. And again, if you were to graph that quadratic, you would see that it has x-intercepts at negative 3 and negative 4. And then here are the other two solved for you. Setting your quadratic equal to 0, making sure there are no common factors, and then finding your factored form, and then setting each factor equal to 0. And so we have a solution of x equals 6 and x equals negative 2 for this one. And again, if you were to graph this quadratic, you would see that it crosses the x-axis at those two places. And same with this one. You get solutions of negative 4 and positive 1. And if you were to graph that quadratic, you would see that it crosses the x-axis at negative 4 and positive 1. And then I've got several here for you to try. We've already done those. So yeah, that's it. That gets us to the end of the second video, day 1, part 2. And tomorrow's video, or part 3, will look at factoring using the area model and factoring trinomials where a, the leading coefficient, is greater than 1.